For more than 4 decades, a silent traveler has been moving farther and farther away from its birthplace, carrying with it the hopes, dreams, and curiosity of humanity. That traveler is Voyager 1, a spacecraft launched by NASA in 1977, and it has now gone far beyond where any human-made object has ever ventured. It was originally designed to study the outer planets of our solar system, Jupiter, Saturn, and their moons, but it has since become something far greater: our ambassador to the stars. And just when scientists thought they had learned everything Voyager 1 had to teach, it sent back a piece of data that was as baffling as it was exciting. Something that, to many, seemed almost impossible. To understand the weight of this discovery, we have to go back to the beginning. The late 1970s were a golden age for planetary exploration. NASA engineers knew they had a once-in-a-lifetime opportunity. The rare alignment of the outer planets would allow a single spacecraft to use a gravitational slingshot technique to visit multiple worlds in a single journey. Voyager 1, along with its twin Voyager 2, was built to take advantage of this opportunity. It was packed with state-of-the-art 1970s technology, a marvel for its time, yet primitive by today's standards. Its onboard memory was just 69 kilobytes, barely enough to hold a single modern smartphone photograph. Communication with Earth relied on a transmitter using only 23 watts of power, roughly the energy needed to light a refrigerator bulb, yet it was capable of sending signals across billions of kilometers. Voyager 1's mission began with breathtaking success. It gave humanity its first close-up images of Jupiter's turbulent atmosphere, its great red spot, and its mysterious moons. It then flew past Saturn, revealing the complexity of its rings and discovering new moons along the way. But after Saturn, Voyager 1's path took it out of the plane of the planets and into deep space, leaving behind the planetary tour to embark on an open-ended journey into the unknown. By 2012, Voyager 1 had crossed an invisible threshold, the heliopause, the boundary where the solar wind from our Sun gives way to the cold, thin plasma of interstellar space. Scientists had dreamed of reaching this frontier for decades, but Voyager 1 was the first to actually do it. It was now sailing through a realm where no spacecraft had ever been, carrying instruments still capable of detecting magnetic fields, cosmic rays, and the faint plasma between the stars. Then came the unexpected. Recently, Voyager 1 sent back data that seemed to defy explanation. It wasn't part of its planned observations, and it wasn't the kind of routine telemetry that engineers were used to seeing. The data came in the form of unusual patterns, sequences that didn't match the normal background readings of interstellar space. At first, mission controllers suspected a malfunction. After all, Voyager 1 is more than 45 years old, and it operates in an environment that is harsh beyond imagination. Temperatures hover just above absolute zero, cosmic radiation constantly bombards its systems, and its power source, a radioisotope thermoelectric generator, is slowly running down. Yet the patterns persisted, and they didn't appear to be random. When engineers decrypted the data, they found something astonishing. The sequences, when plotted visually, formed intricate, deliberate-looking patterns. These weren't the jagged, irregular graphs of random cosmic noise. Instead, they looked like organized symbols, shapes that some described as resembling ancient glyphs, while others likened them to geometric designs found in crop circles. They repeated at intervals, as if part of a coded message. It was as if Voyager had picked up a signal, not from Earth, not from the Sun, but from somewhere in the deep unknown. Naturally, the scientific community reacted with both excitement and skepticism. One of the most respected science communicators of our time, Bill Nye, discussed the discovery publicly, noting that Voyager 1 had apparently detected 300 massive objects in space. The nature of these objects remains unclear. They could be anything from large rogue asteroids to free-floating planets or even clusters of dark, compact material. Some scientists suggest they might be remnants from the formation of our galaxy, drifting silently for billions of years. Others speculate they could be something entirely new, something that challenges our understanding of astrophysics. The implications are staggering. If these objects are natural, studying them could reveal clues about how galaxies evolve, how stars form, and even how life's building blocks might be distributed across the cosmos. But if, and it's a very big if, there is an artificial origin to these patterns, then we could be looking at the first evidence that we are not alone. The rational scientific stance is to exhaust all natural explanations first, but that hasn't stopped imaginations from running wild. Could Voyager 1 have stumbled upon a beacon? A relic of an ancient civilization? Or perhaps a kind of cosmic drift net of signals meant to be noticed by any intelligent species passing through? To put this in perspective, Voyager 1 is now over 15 billion miles from Earth. It takes more than 22 hours for a signal to travel from the spacecraft to our planet at the speed of light. That means every time we send a command, we wait almost an entire day to know if Voyager has heard us and responded. The vast distance makes direct investigation of these strange readings almost impossible. We can't just turn Voyager around or send a new probe to confirm what it's detecting. The spacecraft's instruments were never designed for alien signal detection. They are limited, aging, and far less capable than modern technology. And yet, they've sent us something that has sparked one of the most fascinating scientific debates in recent years. Engineers at NASA's Jet Propulsion Laboratory have been working tirelessly to rule out possible technical glitches. They've examined the Attitude Articulation and Control System, AACS, the part of Voyager that makes sure its antenna stays pointed at Earth. Last year, a strange issue was detected where the AACS started sending back garbled status reports, information that didn't match what was actually happening on board. NASA solved that problem by switching data transmission to a different computer, but the root cause was never fully explained. This new anomaly, however, seems different. It's not affecting Voyager's operations. Instead, it's showing up in the science data, as if something out there is influencing the readings. One possibility under investigation is that Voyager has entered a region of interstellar space unlike any we've mapped before, a zone dense with plasma structures, magnetic anomalies, or even gravitational disturbances caused by unseen masses. These could be natural signposts, of sorts, telling astronomers more about the shape and content of our galactic neighborhood. If this is the case, then Voyager has given us a priceless treasure, the first direct survey of a truly alien environment. But there's also the tantalizing possibility that the anomaly isn't entirely natural. Some astrophysicists have pointed out that the patterns in the data have mathematical qualities, ratios, repetitions, and symmetry that are unusual in purely random cosmic noise. If true, that would raise a monumental question: who or what created them? The odds of intercepting an intentional signal in such an immense universe are mind-bogglingly low, but not zero. After all, Voyager 1 itself carries a message from Earth, the famous Golden Record, with images, sounds, and greetings in 55 languages, meant to be found by any extraterrestrial civilization that might encounter it. Could another civilization have done something similar, leaving behind breadcrumbs of information for travelers to find? Of course, extraordinary claims require extraordinary evidence, and scientists are being careful not to jump to conclusions. The coming months and years will involve careful analysis, cross-checking Voyager's data with that from other observatories and space missions. Unfortunately, Voyager's time is running out. Its power supply is expected to dwindle to the point where it can no longer run its instruments sometime in the 2030s. Each piece of data it sends from here on is precious, a final gift from a spacecraft that has already rewritten our understanding of the solar system and beyond. Whether the mystery turns out to be a quirk of physics, an undiscovered natural phenomenon, or something truly extraordinary, it reminds us why exploration matters. Voyager 1 is a machine built by human hands, yet it has traveled to a place no human has ever been, carrying our curiosity and our questions into the dark. It speaks to something deep in our nature, the desire to know, to push boundaries, to seek out the unknown even when the answers might be unsettling. The fact that Voyager 1 is still talking to us at all is a triumph. Think about it. A spacecraft launched when the first Star Wars movie was still in theaters is now operating beyond the influence of our sun, still returning science that challenges us. It has outlived its designers, outlasted its original mission, and outperformed every expectation. The strange data it has just sent back is more than a puzzle to solve. It's a reminder that the universe is vast, mysterious, and full of surprises. And so, the story of Voyager 1 continues. Somewhere, in the black expanse between the stars, a lonely spacecraft drifts onward, its faint radio whisper still reaching home. What it has found, and what it might yet find, could change our understanding of the cosmos forever.